All right, let's talk about applications of a percent increase or a percent decrease. So now we're going to use those percentages. So first, let's revisit. Percent means per 100. So when we're talking about percents, we often refer to part over whole, where the whole is 100. And that part, whether it's less than 100 or more than 100, is located in the numerator. So thinking through, if we have a 30% increase, that means we take the base, right, the whole of 100, and we add 30. So that would give us 130%, or 130 over 100 in the part to whole, because the increase means more than the whole. Now, if we're talking about, let's say, a 15% decrease, same idea. We start with our whole of 100, and because it's a decrease, we would take away. And that would give us 85%, or 85 over 100. So with percent decrease, we're dealing with less than 100, and dealing with a percent increase, we're dealing with more than 100. Let's look at some examples. Ticket prices that were $140 last year rose 20% this year. What are the ticket prices this year? Well, okay, think about this. They rose 20%. That's an increase. So that means if our base is 100 and they rose 20%, that means we're dealing with 120%. So I will take this year, right? Ticket prices that were this last year, they rose. So we're going to multiply by 1.2 because 120% is 1.2 as a decimal. And that gives us a ticket value of $168. So that's the cost of the ticket prices this year, because we have this 100, right, which is the 1, represents what they were, the 140. The 20% increase is the 0.2, which is how much they increased. Now, you could also think about this a different way, and you could say if there were a 20% increase, I could just multiply by the 0.2, which is the increase, and that tells me that they've increased $28. That's just the amount of increase. So then I would take, they were 140, they increased 28, and that gives us the total of 168. So this example really has two different ways you could do it. I tend to stick with way number 1, just makes it a little easier. Now let's look at the second example, which is a little trickier. Airline tickets for my annual trip are $400, 15% lower than last year. What were last year's prices? Okay, so now think about this. We are now talking about 15% lower than last year. Now, this is a decrease. So lower means we take our 100, we subtract the 15, and that's where we have the 85%, or the 85 over 100, or the 0.85 as a decimal. Now, that is then last year. So 0.85 times last year. I'm going to use an L for last year. So if we take 85% of last year's prices, that means we get this year's prices. Okay? So if L stands for last year, that's how we go with this. Now to solve this, we would divide both sides by 0.85. And that means last year's tickets were right around $470.59, rounded to the nearest penny. Now, one other way you can think about this, okay, is to say, okay, if I take last year's, right, and 15%, I'm going to subtract 15% of last year's. That will give me the 400, right? So L stands for last year's ticket prices, which we don't know what they are. Now, if you do this, last year's minus 15%, because that's the low, right? That's the decrease. When you subtract 1L minus 0.15L, you get 0.85L, which is exactly what we did in method 1. So whether you think about it the first way of subtracting it from 100 to begin with, or you think about taking last year's and then subtracting, you get the same thing, where last year's ticket prices were higher, right? And if you want to check your work, you could take 470.59 and multiply by 15%, because that's the decrease. And if you do that, you get, and if we round to the nearest penny, this is the amount of decrease. So if you would subtract 470.59 minus 70.59, you would get 400. So that is how you could check your work if you want to make sure it all works.